So now we're going to solve an equation involving logarithms. So we're going to have log in base 2. Logs in base 2. So it's log in base 2 of 2 plus log in base 2 of 3x minus 5 equals to 3. So our goal here is to rewrite this so that it's in the form log of something equals log of something else. And what we want to do is get rid of the logs after that. So use the one-to-one property of logarithms to say that that a is equal to b. So I would hate like students like crossing out the logs as if like you'd be dividing by log. It looks really strange if you do that. So this is really like using the one-to-one principle of property of logarithmic functions. So that's our first goal, like rewrite this as a single log on each side maybe. So in particular here I've got the log of the sum of two logs, right? It's like as if I have log in base 2 of m, log in base 2 of n, and we know that the log of a sum is the log of the product. So I'm going to be able to rewrite at least the left-hand side as a single log. Obviously, if I would have like other logs here, I would bring those all on the same side, okay? But here I just have 3 on the other side. So this is going to be 2 times 3x minus 5. And maybe put that all in brackets so that you know that log applies to all of that. And that's equal to 3. Okay, now at this point I have 2 solutions, 2 ways of approaching this. Number 1, I could just convert to an exponential equation. Okay, so I would say that 2, so 3 is the power, right? 3, it's a log, so it's a power to which you raise the base 2 in order to get 2 times 3x minus 5. Okay, and then we end up with a linear equation, right? Because it's just 8 is equal to 6x minus 10, and that's super easy to solve. So we get 18 is 6x, and finally x is 3. Okay, and I'll tell you here that your solution, you have to be careful. Okay, we'll come back to it. Solution number 2 is to try to have logs on both sides, like log of a equals log of b. So I can convert the 3 into a logarithm. How do I do that? Well, you can use the principle that x is always going to be log in base b of b to the x. So if I want to write 3 as a 3 in base 2, well, it would be log in base 2 of 2 to the 3 of 2 to the 3, like that. Okay, so that's the same thing as 3. And then you've got 2 logs with the same base. That's important, right? Base 2 on each side. So you can get rid of the logs because the logarithm function are 1-to-1. So you get this again. So you get the same equation, of course. Okay, it's just obtained slightly from a different perspective. Okay, and then after solving, you would get again that x is 3. Now for your solution, x equals to 3, you just have to be careful because in your equation here, there are implicit restrictions. If you look at the expression on the left-hand side, there's a log of 3x minus 5. Okay, that's not always gonna be something you can evaluate, especially if the input, if 3x minus 5 is negative, because if you remember, a logarithm has a domain. Okay, the domain of a log, okay, a log function is all numbers above 0. Okay, so here this implicitly the 3x minus 5, okay, is something that's positive, okay, for the expression to exist. Okay, so so here 3x minus 5 is greater than 0. Okay, so that means that 3x is greater than 5. So x is going to be greater than 3/5, okay, for this expression to be to actually exist, okay. Otherwise, the log of a negative number does not really exist. There's no such thing, at least for in this course. So when you get back to your answer, you have to verify, is my, okay, the answer that I have, does it fit into the domain? So here we could compare it. Is 3 greater than 5/5? Yes, it is. Now that involves like doing some work, but there's an easier way of doing that. Once you get your answer 3, you could just replace it, okay, into the equation, just to make sure that you don't get a log of a negative number. And if that's the case, then you know you've got your solution. Okay, so verify your answer to make sure no logarithms are evaluated at a negative number. So here, like literally, you'd go log in base 2 of 2 plus log in base 2 of, and then you replace 3 times 3, 9 minus 5, and you can see that it's going to work. Okay, so so you get log of 4, and you can actually tell that the answer is it's kind of nice here, because you've got in the argument here always a power of 2. So log in base 2 of 2, that's just 1, and since this is 2 squared, log in base 2 of 2 squared, that's just 2. And it allows you also to verify that you get exactly 3. But the important part is to verify that here you don't have like this. Well, this is positive. This is the part where x was replaced by, and it's positive.